Hello everyone. Welcome to minipyhub. So what we're building today is an advanced periodic table app using Python. We're going to use a built-in library called tkinter to create the graphical interface. That means buttons, search bars, pop-up windows, everything you'd expect in a basic desktop application. We begin by importing a few necessary modules. First is tkinter, which we use to build the GUI. Then MessageBox, which allows us to show pop-up alerts. We also import web browser so we can open Wikipedia pages for the elements. Then there's JSON, which we use to load data about the elements from a file. Finally, we use path from the pathlib module to handle file paths easily and safely. Next, we define a dictionary called category_colors. This is just a collection of colors that are assigned to different categories of elements. For example, alkali metals, noble gases, nonmetals, and so on. So when we later create buttons for each element, we'll color them based on this dictionary, making the table more visual and easy to understand. Now we load the actual data for the periodic table. There's a file called periodictable.json that contains all the elements and their details, like name, symbol, atomic number, row and column position, category, and a fun fact. We open that file, load its contents using json.load, and store it in a variable called elements. After that, we define a class called periodictableApp. This class will manage the entire app, from setting up the layout to handling what happens when the user searches or clicks on an element. Inside the init method of this class, we start by storing a reference to the main window, which we call master. Then we give the window a title and set its background color to black. We also create a variable called searchvar, which will store the text the user types into the search bar. Finally, we call a function called createWidgets to actually build the interface. Now let's talk about createWidgets. This function first creates a small frame at the top of the window. Inside this frame, we place a label that says search and a text entry box where users can type the name or symbol of an element. We connect the entry box to our search var, and we also tell it, hey, when the user hits enter, run the search element function. After that, we loop through all the elements we loaded from the JSON file, and for each one, we call a function called addElementButton. So what does addElementButton do? Well, it creates a button for that specific element. It looks at the element's category, finds the right color from the category colors dictionary, and sets that as the button's background. We also tell the button what to do when clicked. In this case, it will run the showInfo function and pass the element's details into it. Each button is placed inside a grid layout, with the position decided by the element's row and column from the JSON file. We also add two events to the button, one for when the mouse hovers over it, and one for when it leaves. These events help us show and hide tooltips. Now let's look at what happens when you click a button. This is where showInfo comes in. This function displays a pop-up message with detailed information about the element, its name, symbol, atomic number, category, group, period, and a fun fact if one is available. At the end of that pop-up, we ask the user if they want to see more. If they click OK, it opens the element's Wikipedia page in their default browser using webbrowser.open. Next up is the search element function. When the user types something into the search box and presses enter, this function gets triggered. It takes the input and checks if it matches the name or symbol of any element, ignoring uppercase and lowercase. If it finds a match, it shows the info for that element. If not, it shows a warning message that says, no element found for that input. Then we have two more functions, showTooltip and hideTooltip. These handle what happens when the mouse hovers over or leaves a button. When you hover over a button, a small tooltip window appears near your mouse cursor. It shows the element's name, symbol, and atomic number. When the mouse leaves the button, we destroy that tooltip window. Finally, at the bottom of the script, we have the main part of the program. It says, if this file is being run directly, not imported, then create a window using tktk, create our app inside it, and start the GUI loop with mainLoop. This keeps the window open and responsive to user interaction. So in summary, this code builds a fun and interactive periodic table app. You can click on any element to learn more, search for elements by name or symbol, and even visit Wikipedia to explore further. Hope you have enjoyed this video. Don't forget to like, share, and subscribe.